It's my pleasure to be able to visit a little bit about amino acid research. Every year at this meeting, we try to give you a little bit of an update of some of the work that we've done in the past year in the amino acid side. And a bunch of the papers that you're going to see in the Swine Day publication covering a number of these areas. I'm not going to talk about all of them, but I'll give you just a little bit of background on the valine and isoleucine, which led to what I want to spend the most time on is this validation of amino acid ratios. Everybody uses a little different ratios and try to understand exactly where they should be at. And I think that trial helps me put some of it all together. Certainly on the amino acid side, we work with a number of different groups, and I want to give them all credit for Ajinomoto for supporting a lot of the research. Most of the trials that I'll share with you are done either at Kallenbach Feeds, Holden Farms, New Horizon Farms, or at our K-State Swine facility. Okay. So in terms of doing amino acid research, the first thing you have to know if you're going to do ratios, of course, is what your lysine level is, because you can't be above the lysine level if you're going to look at a ratio. And so we've done a lot of trials looking at our lysine requirements and different, as we change our genetics and as the genetics change over time. And we see the similar type of curve in terms of the lysine response. Here's one that Annie's research that showed that we probably are starting to break out here between 1.4 and 1.6. This data was linear, showing that we had up through our 1.6%. We did not see hit a maximum on performance. But as you look at this, if we're going to do amino acid titration trials, we decided to pick about a 1.25% lysine to make sure that we were below the requirement. Instead, and it'll show you when we get to our validation that if we go up much higher than that, we start changing what our ratios tell us. Okay? So we take that 1.25% lysine diet then and then titrate some of these other amino acids. And I know there's some of you in the audience that have been involved with a number of amino acid titrations over the years. And the valine requirement, this one shouldn't surprise you a whole lot. It breaks right around that 63% SID valine to lysine. And when you do the break point on this, Annie showed it was right around 63% for the maximum growth rate. And with valine, it's almost all driven by a feed intake response, a big chunk of it. Do get a little bit of a feed efficiency response, I'll show you, but a big chunk of valine, tryptophan, isoleucine, we always talk about those amino acids are the drivers on feed intake. You go too low on those, you really hurt yourself bad in terms of performance because intake drops quite dramatically. So here we see that it looks like for feed intake, 63% is high enough. When you look at feed efficiency, and this becomes important when we start looking at some of our other slides, is that the feed efficiency response may respond to a little bit higher level than what we saw on the feed intake and growth rate for valine. But this trial, again, was done to be able to show the shape of that curve so that we could look at what level do you need to get 100% of that maximum response, to get 95% of the maximum response, or to put economics to it, say what level is the most economical one to feed given the price of each of these amino acids. Okay? Isoleucine. Isoleucine is another one that we normally don't think about when in terms of formulating diets, except now that we've got synthetic lysine, methionine, threonine, tryptophan, and valine all commercially available. That means isoleucine is our next limiting amino acid in an awful lot of situations, so it's very important to what level that is in formulation. And this is one that, again, when you fall below the optimal level, you fall off a cliff in terms of performance. The reason we thought it was important to go back and look at isoleucine again is we've done some of these trials in the past, but the problem usually with isoleucine is to make a diet that's low enough in isoleucine, you usually have to involve an ingredient like spray-dried blood cells or something that is also extremely high in leucine, which gives you problems because if you put a diet that's too high in leucine, another branched chain amino acid, it artificially increases the ratios required for your other branched chain amino acids for valine and isoleucine. So in this case, Annie was able to work with Hans Stein, had done some work with peas, and was able to give us a very good amino acid and digestibility values for the peas that they had. And so we used those to help lower the isoleucine level. Because if you don't have these low levels, and you started titrating at 48% as an example, you'd have no response. So you need these low levels to be able to dictate that. But it showed us very clearly that as long as we don't have very high leucine levels in these diets, 52% was high enough. We did 2 trials. It's kind of ironic that this 52 bounces up over the 54. I don't understand why. It did that in both the experiments that Annie did this last year, and we still don't fully understand what's going on up above here. We wouldn't expect any change once you get past the 52%. But certainly 52 looks like it's enough, and it's again 100%, and this trial was driven by feed intake. Absolutely nothing on feed efficiency. Okay? So this is a very busy slide, but this is the one I wanted to get you to because I think it helps me really understand and put these different ratios and the whole argument about what ratios should you use, and it depends a lot on where your lysine level is at in your diets. And so in this experiment, this was done, we did in the field, about 2,500 pigs in this study. This one is not in your Swine Day publication because we just finished it a couple weeks ago, but I thought it was an important one to share with you. Is we have a control diet here. This is a 135 lysine control diet that has HP300, the hamlet protein, as our control, so it has a relatively moderate level of synthetic amino acids. Okay? We then replaced that hamlet protein with all synthetic amino acids over here on the far right. Okay? So you have the 135 lysine, and then we also had a 125, which we know is deficient for these pigs. Okay? And so then we had, within each of those, we had 3 different lysine, amino acid to lysine ratios. And so we have our low levels, which we call in industry in this example, and this where we had methionine and cysteine at 55%, and you can read those levels down, the tryptophan, the valine levels, and the isoleucine to lysine levels, basically about as low as we thought that you really want to push them without falling off the edge of the cliff on each of those amino acids. Then you take the other end of the extreme. These are from Annie's research and from Marcio Gonçalves' research and the other research we've done over the last few years that looked at what's the maximum level of each of those ratios that we don't think you should get a response beyond that. Okay? And so those ratios, you can see, are going up to 65% on threonine, 21% on tryptophan, 72% on valine, and again, we left the isoleucine down at that lowest level. We then have the 95% of max, and it's exactly what it indicates. So you took each of these amino acids, and based on our research, where do you expect to see 95% of the maximum? It's not only where you expect it, but with all the work with Nora Bayo in the statistics department, what our stats tell us is where the 95th percentile falls. Okay? And so we did that with the intermediate levels, and you'll see that the ones that really change the most on the intermediate levels are the tryptophan and the valine levels. Small changes, but as you look at the performance response, and again, we'll focus here first on this 125 lysine, the deficient diets, you see that going from those lower levels to the 95th percent of max, we see an improvement in average daily gain. You see a smaller incremental change, but not significant improvement as you go to the maximum levels in those diets. Then you go out to the 135 lysine, which would be fairly close to what a lot of our diets would be formulated at in the industry in this phase, a 15 to 25 pound pig. 135 lysine diets, the ratios going down to those lower levels didn't hurt us. Okay? Which again makes sense. If we're a little bit closer to that pig's requirement, we're not below the requirement, the ratios aren't quite as critical to hit them exactly. We can have a little bit of play in there. Okay? And when you look at where the response came from, interestingly is when you go from the industry level to the 95th percent of max, it was mostly a feed intake driven response going on here, and I'll show you in the next slide, there's a little bit of efficiency there. But you start thinking about the feed intake differences, what we would expect with the tryptophan and valine showed up. Fortunately, the pigs did read the protocol on this one and responded the way that we hoped they would. Okay? But you look at the feed efficiency side, the feed efficiency, you see most of the benefit of the change over that industry level on this lower lysine diets came when we went to the maximum levels. And again, the levels that probably are driving a bunch of this, you got the threonine. We know threonine and valine, we know that the response for feed efficiency is a little bit higher than what it is for growth rate and feed intake. And so again, it seems to make sense based on the ratios. Okay? So the summary from the 15 to 25 pound pigs, we know that the requirement of these pigs for maximum growth performance is between 145 and 1.6 lysine. The reality is we formulate a lot of those diets closer to about a 135 lysine for a couple of reasons. We don't want to challenge the pig with quite as much protein in that stage is one of the reasons we don't formulate for maximum performance. And we know that those pigs do have a little bit of compensation with the higher levels later in the nursery. And so we can get by with a little bit lower lysine at that stage. But when you do that, you got to be careful on your ratios. The valine to lysine ratio in Annie's work showed from 63 to 72%. The isoleucine to lysine was around 52%. But the results depended on which model and which criteria that you used. And higher ratios definitely are required when lower lysine diets are fed. Switch then from the nursery pig to all the way to the late finishing pig. Probably the biggest areas that we struggle with in terms of formulation is not only getting those pigs up on feed immediately after weaning, but then the other end of the spectrum is just how cheap can we make the diets, how low in amino acids, how low in protein can we go in those late finisher diets without having problems. And this, in order to do research out there, again, you have to know what the lysine requirement is. And so Jose Soto has been doing a lot of work in this late finishing pig area. This is with the DNA finishing pigs we've got out at our research farm now, and you can see that for average daily gain for that late finishing stage here, 225 to 280, 0.55 SID lysine was adequate. These pigs had pretty high feed intake in the trial, but it was adequate in order to maximize growth performance in this experiment. For feed efficiency, you see that you may want to push it a little higher. I probably wouldn't be feeding a 0.55 SID lysine in this stage in the field because the feed efficiency benefit does pay to go a little bit higher on this level. But again, it's important to know what the lysine level is so we can look at the other aspects. One of the aspects that we wanted to look at is just how low can we go in crude protein. And this is an area that there's again been research done for over decades now. University of Illinois did some very early research that showed you may be able to drop it down to 10.5% crude protein and still get adequate performance with a lot different pig than we have today. Aaron Gaines, I know you're in the audience here somewhere. Aaron, I know there was, with the University of Illinois, did a really nice study a few years ago that showed about 11% crude protein looked like was where as low as you could go. This data showed us pretty clearly we don't want to fall below 12% crude protein in this 240 to 280 pound weight range. The real interesting part about this is when we went back and looked at that data that Mashoffs had done with Illinois, the 12% crude protein diet in here looked almost identical soybean meal level to what their 11% crude protein diet was. And so I don't know differences in labs and analysis or just differences in crude protein of the soybean meal that was being used in different experiments, but I thought it was kind of ironic that those diets look almost identical to where the lowest level of crude protein could be. So what happens when you go too low? You see that growth performance drops off quite dramatically. We don't understand exactly what's going on here with why it's fallen off so much, because these diets all have the same synthetic same amino acid levels. They're supplemented with synthetic amino acids to keep all the amino acids above what we think the minimum ratios are, and actually they were all kept at the same ratio as used in the 13% crude protein diet in this example. Okay? And it was all driven by feed intake. When we took the soybean meal out of the diet in this example, the pigs didn't want to eat the diet as much, and so we dropped down feed intake, and so you see that they did not grow as much because intake's dropping. We also see the feed efficiency, and that's really the big hit when you really drop low in crude protein. You see this big drop off in poor feed efficiency, and from a feed efficiency standpoint, you argue that it may be higher than 12% crude protein that we may need. But one of the things that we're doing with this experiment then, and now Jose is going in and looking at different aspects of trying to understand what is going on, what's missing in this 10% crude protein diet. And I know there's a number of people in the industry trying to understand this because we should be able to use synthetic amino acids and make this diet perform similarly to what we see on the 12 and 13% crude protein diets. One of the areas that Jose did early on is in our Swine Day publication is looking at the electrolyte balance. The electrolyte balance differences here aren't great, but when you take a diet that's 13% crude protein formulated with a reasonable amount of synthetic amino acids, you see that the electrolyte balance is relatively low, but if you drop out that crude protein and add more synthetic amino acids and don't change anything with the electrolyte balance, it drops that down to about 48. And so Jose wanted to ask the question, is that what's causing this poor performance? So increase the electrolyte balance up to 107 to be the same, absolutely no improvement in performance. And you could argue that we saw there's no difference significantly here between these treatments either, but didn't really give us any benefit to improve the electrolyte balance that little bit. And you can see from a feed efficiency standpoint, we again see the big difference between the 10% crude protein and 13% crude protein, but no change due to electrolyte balance. So that we weren't able to fix it with that. So right now we're looking at other protein sources and seeing if we can first off, we can replace the soybean meal with other protein sources and get the same performance, and then use some of those and see if we can titrate out if there's really something magical about that 12% crude protein minimum, or if it's something about soybean meal that the pigs particularly enjoy. So late finishing pigs, just a quick wrap up. 0.55 to 0.65% SID lysine was required for 240 to 280 pound pigs. Last year we had some papers, and I think they're in this year's Swine Day, with 0.65%, some of the PIC pigs that we've done the experiments on in that late finishing stage. And then the dietary crude protein, based on what we know right now, I wouldn't formulate a diet, corn soy diet with less than 12% crude protein in that late finishing stage. And electrolyte balance was not the reason for the poor performance for pigs fed these low crude protein diets.